This video is about Firefly Perimeter. There are a few slides I'll go over to give a level set on the product, some information about performance, the architecture, and some overall details about how the product was built. Then I'll switch to a live demonstration to give a better understanding of the look and feel of the product and how a policy is actually enforced. Go through some of the basics on the CLI as well as the different user interfaces that we have for the product. So the product was launched officially to the public in January of 2014. It's part of a series of 3 different products: Firefly Host, Firefly Perimeter, and Virtual Director. There are videos on Firefly Host and Virtual Director, so you can find out more information about those. I won't cover those in this section. This is only Firefly Perimeter. So Firefly Perimeter at a very high level is an SRX, a physical SRX in VM format. So you can think of taking an SRX 240 or 550 from our product line, take away the sheet metal and the power cable, and you have Firefly Perimeter. Make that in a VM, and the great thing about this is you get all the flexibility of being able to run this in a VM and put it in the cloud or put it on various different infrastructures to have the VMs use that Firefly Perimeter as their default gateway for all traffic that they process. So because it's in a VM, it's bound at about 5 gig. That's very different from Firefly Host that operates in the kernel, but you get the flexibility of the VM format. You don't have to make any kernel changes, no dependency on any API integrations there. So for use cases where you need north-south filtering at about 5 gig of performance, and you also need connectivity, things like NAT, routing, VPN, all those pieces are inherent in Junos and all are available in the Firefly Perimeter product. So you can think of this as the north-south and connectivity feature set in VM format. So to give you some ideas about what the actual VM consists of, it's 2 virtual CPUs, one for the RE and one for FlowD, and at this point there is not an ability to add multiple virtual CPUs to the VM. There's an architecture that I'll talk about a little bit later where in the future we envision being able to scale the performance up beyond 5 gig by adding multiple virtual CPUs or virtual cores to the VM. The memory is also at 2 gig right now. This is for x86. For x47, we'll be looking to expand this as we add new services to 3 gig. Longer term with that new architecture, this will go much higher, 8 gig, 16 gig, those sorts of things, once we move from the existing operating system that the product is built on. The disk is small, it's 2 gig. The idea is that you'll have a central logging device, so you won't be dumping all your logs into this VM. You can use Secure Analytics or a SIM of your choice to take all the firewall logs and event information. There are a number of NIC configurations that you can do, from 2 to 10 virtual NICs. The product is supported on the VMware platform, the KVM platform, and Contrail. So all 3 of those, whether you're using Contrail on top of KVM or just plain KVM without Contrail, all 3 of those iterations are supported. The VM itself can take multiple virtual NICs. That is one item that's configurable. The CPU and the disk things are not configurable, but you can add multiple virtual NICs to the VM. There's different ways to deploy the product using Vsphere Client or Virtual Director or OpenStack. Hardware layout is as you see here, so keep that in mind. Now, what did we have to do in order to make this Firefly Perimeter VM? Well, we spent quite a while mapping the infrastructure that it was inherent to the physical SRXs and manipulating it so that it would be able to deal with x86 and virtual CPUs that are added to the VM. So there are a number of things on here: code changes for affinity to make sure we don't have drift, driver optimization, and x86 CPU architectures to remap the Junos code to deal with those pieces. So a lot of timing things, virtual environments are notorious for clock drift on the CPU, and of course that will impact all sorts of counters and VPN mechanisms and all sorts of different pieces. So it's important when you set up Firefly Perimeter to make sure you configure NTP and you get the timing set so your logs are set correctly, and all the aspects of the product will function correctly. Okay, from a feature perspective, the Firefly Perimeter VM is on par with the branch feature set. So right now, the x86 version is missing UTM, IDP, and AppSecure, but all of those services are being pulled in to a new release in 2014. In the May timeframe of 2014, we'll have UTM and IDP, and then AppSecure will follow shortly thereafter. And that will fill out these gray boxes in here where it's mainly the services that we're missing now. So you can see that the goal is clearly to have a complete parity between virtual and physical, and we're quickly closing that gap. We have the firewall, the core feature set, if you will, firewall, VPN, and NAT, and all the same management tools in addition to Virtual Director that we built specifically for the virtual environment. So really, Juniper sees virtual or physical just being a choice that a customer takes depending on their use case and their demands for their network. We envision having the same set of management tools to control these, and the same set of features so that your experience is uniform across the different platforms. So from a performance perspective, all the work that I was discussing around CPU usage and operating system pieces, we're in really good shape from a performance perspective. At the moment, the VMware version is up to 4.9 gig, and KVM is 1.1 gig. We are still looking at optimizing that code. It didn't get an optimization run in it before we released the x86 build. So there's some work that we have to do to bring that up to par. I'll talk about the new architecture, which will get us hopefully leagues better than we are all on all fronts. But really, from a competitive perspective, the data sheets of Cisco and PAN and other vendors out there are all kind of in this ballpark. This is just a function of running VM. And from a scale perspective, we do have a cap of memory right now that basically throttles some of those levels. But for pretty much the majority of use cases that are out there, this performance footprint is really good and is going to meet those use cases. There's extremes that will always exist, and for those we really have and recommend physical gear, right? The Firefly Perimeter is not trying to be an SRX 5800 in a VM, right? This is not what we've built and released at this point. The Firefly Perimeter is more like a 550 or a 240 in that range of the SRX series, but it comes with all the flexibility of being able to instantiate this in a matter of moments with software and tie this into an SDN network. And so for those types of use cases where you're onboarding thousands of customers and you need a dedicated firewall appliance for each of them, that's a beautiful use case for the product. And there are also many times where you have multi-department firewalls and just the need to instantiate one of those Firefly perimeters for each department, and not huge bandwidth requirements for those types of deployments. So it depends on your use case. It's important to understand that, and you can see the performance here, and of course Juniper's always striving to push the boundaries on these things. From a density, this is how many VMs you can stack on a single x86 box or in an actual rack. And so this is an important factor in determining the TCO of a solution. And on that front, we've tested a number of different iterations, some different types of servers, and tested out different VMs on there. One of our latest set of testing was a rack optimized server, that one of these super micro boxes, and we have about a $40,000 box around there for 2Us. It's really actually different systems inside that 2U space, but the net of it is 500 Firefly VMs in that kind of a footprint. So that's pretty high density and a good story on that front to have multiple Firefly perimeters running together. So even with that said, I mentioned we're always looking to kind of push the boundaries on these things, and in order to take a jump in scale and also to be able to leverage multiple CPUs, Juniper's working on what we internally codename call Daybreak, but for the outside world, it's really the next generation platform, and this is on both a physical and a virtual path. And for the virtual aspect, we are working on this for the beginning of next year. And so at that point, you'll probably see another large jump in scale and performance across the board. That will hopefully put us that much farther in front of the other use cases that no doubt appear. Okay, so how do you manage the Firefly perimeter? So the security director, the sets of APIs that we have, the Cli Web Interface, all of these, I'll show you the security director and Cli Web pieces. All of these are the same as what you would use for a physical SRX, exact same interfaces. The unique thing is we built Virtual Director, and that helps you automatically deploy the Firefly Perimeter VM all from the space application, and I'm not going to show that. There's another video on that, but these management tools are all going to be in play in the demo. The thing I'll talk about is we do have HA as a feature for the product. Where release it was part of X46, and for KVM it will be part of the X47 release, which is in the May timeframe. So HA perspective, it's the exact same chassis clustering that we use on the physical SRXs. So this is not VMware HA or VMware FT or any of these things that are being used. This is actually the technology that we used on the physical world. We just layer that same infrastructure into the virtual world. So you use virtual switches and connect control and fab and all links together in the virtual environment. You can build your cluster members on different physical hypervisors, or the same hypervisor, doesn't matter, but likely you're going to build them across different physical hypervisors. So if one of those goes down, you still have stateful failover. That's the big difference between chassis clustering and Juniper's solution and VMware HA. The FT solution doesn't really work that well in practice because of performance on especially network intensive applications. So again, we're using chassis clustering and state synchronization for the firewall tables all through that technology. So you get fully stateful firewall failover, no issues when a node or a whole server goes down. So that's a good feature and available on VMware now and KVM this May. Into the demo now. I'll just switch from the PowerPoint slide, and what I'll do to start off is have a Windows Fusion window here, and there's a couple layers of virtualization, but what I want to start with is the Vsphere Client. So this VM right here, Engineering 1, is actually a Firefly Perimeter VM. It's X46D10. So that's our very latest build. You can see it's based on FreeBSD 32-bit. That is part of that new architecture. We'll look to raise that up to 64-bit to be able to add more than 3 gig of RAM to it and be able to kind of lift all the scale numbers up. You get the idea. It's a virtual machine in here. There are the same sorts of tasks and telemetry that you can get on any VM is still available here. So any of the vSphere tools that you use to monitor a VM as far as what it's up to, any alarms that it's hit triggered, all of that is available. You can see this is just on a FF Demo 1 storage area. Doesn't matter if you put it on a local store or a NAS, you can vMotion the VM around. You can also vMotion VMs that are protected by this around, as long as the network between those servers that you vMotion to and from is the same, then the packets will route back to the Firefly demo to be analyzed with the various policies. So in addition to that, we are working on transparent mode as well, so that you could have bridging of vSwitches in here. So an area where you had multiple vSwitches and bridge the interfaces of a Firefly perimeter between these vSwitches and have the traffic flow over them. Put PNIC on one of the vSwitches and no PNIC on the other one, and then the only way for the traffic to route outbound off that hypervisor is if it flows over a transparent mode Firefly perimeter. But that's also on track for the May release. But right now you can see it's pretty simple. It's just a VM, and of course we could instantiate this with Virtual Director in here, or you could just deploy it off a template. All of those items are supported because there's no real change from that perspective. So I'm going to now actually show you the next piece, which is I'll just log into the CLI. So I'll go CLI Web Interface Security Director in that order. And so if I click on this Engineering 1 and open a console to it, just log in here, go to the CLI mode. There are a number of commands. This is just general SRX. I could SSH to this or even telnet to it. But the idea is you have your CLI. This is SRX CLI. And if I just do a show version, you'll see right off the bat that this is the model is Firefly Perimeter, right? So it's not a 5800 or anything else that you would see in those types of models. The next thing you can do is take a look at hardware detail command, and instead of showing you hardware details, now that we're a VM, we're showing you the fact that we have a virtual hard disk, some information to basically indicate that this is a VM that you're connected to. I could even do the something else very simple. Some of the routing engine, you see the Firefly Perimeter RE in there. Those pieces all exist. So there are some CLI changes that indicate the system as a VM. Okay, so CLI, all the scripting and all those pieces, expect it all to work the same way with some minor additions for indicating that it's an actual VM. Okay, so from the next piece, the JWeb interface. We'll run the JWeb interface over here. So that Firefly, that engineering VM that I had logged into is right here. I'm going to just go in now instead of with the CLI, with the JWeb interface. And the JWeb interface, it's all the same as you would normally expect. There's different tasks and dashboards and so forth that you can use to actually monitor the system. All of this information is available at a per tenant level as well. So managed service provider, and the service provider wanted each of the individual tenants to manage their individual firewall. Well, they could CLI in, or they could use the JWeb interface to manage those themselves. Now, in the case where you have hundreds of these and you want to manage them all for the departments or tenants or so forth, then you'll want to be able to use the space infrastructure. So I'm going to flip over into that at this point. I'm not going to go through all the steps of JWeb. I'll just log into this system. So space is the central kind of repository for different applications that are used to manage the various Juniper products. You can see in the pull down here, we do actually have Virtual Director here. I'll just switch to it so that you can see that this is how you could deploy out the virtual machines in the environment. There's a device already that's been deployed. That Engineering 1 Firefly Perimeter VM is already configured. It was deployed out using Virtual Director. I'm going to switch to Security Director at this point and just do a very simple, the classic firewall demonstration test, the drop of ICMP traffic. So here's a Firewall Editor. I can come in here and I can see that there's a device already. So if I go to Device Management, we'll see that Engineering Firewall. I can come in here and take a look at that device by, say, show me the active configuration and see there's Firefly Perimeter commands that are shown here, or some indication that these are Firefly perimeters. You can see the actual config itself. So some people will have scripts and so forth that just edit these types of parameters. All that's available. But of course, I'm going to change the firewall in this particular environment with the security director user interface. So before I change it, you can see in this just real simple environment, in the all device policy, I have an ICMP ping permit. I have a VM in this window, which I'll flip back over into this environment and show you this VM called Firefly Win7. So I'm going to just open a console to this guy. It happens to be a Windows box, and its default gateway is that engineering Firefly Perimeter VM. So when he does a ping at this point, ICMP traffic is allowed, so the ping is going through just fine. If I go now into this rule and I lock it and change this permit to a deny and save it, and I'll actually go and push this policy out. So I'll publish the policy to that engineering firewall device. So it's going to go out, and it'll give me a job ID. And I can flip back over. The policy has taken effect, and so now the ping is dropped. So pretty simple standard firewall test. There's all sorts of other configuration items here for configuring VPNs and all the different aspects of the firewall. I just wanted to show a short test in which the firewall was manipulated to protect a VM or manage the flows coming out of a VM. And as soon as that firewall change goes into effect, you'll see that it starts to allow the ICMP traffic through the firewall. Okay, so that's it for the demonstration. One last reminder that I want to put up on the screen for where to get all of this stuff. You can go to juniper.net/firefly and download any of the products. There's just a click-through license agreement to get access to download and begin trialing and doing proof of concepts on the code itself. Virtual Director, all those pieces can be downloaded and installed. Thank you for taking time to view the video.